In this video, we're going to talk about section 3.4, which is division and exponents. So chapter 3, we have been exploring math operations, and now we're finishing with division. And once they do division, they also like to discuss exponents. So for division, I went ahead and wrote out the definition. For any whole numbers R and S with S not equal to 0, so that's because we're going to divide by S and we don't divide by 0. The quotient of R divided by S, so I like how they threw the word quotient in there. Most people are aware that that is the math word for division, which is denoted R divided by S, is the whole number K such that R equals S times K. Now, just to kind of add a little bit of terminology to this, we call R the dividend. The dividend, that's a V. Wow, weird floating V. Okay. S is called the divisor. We are dividing by. And then K is referred to as the quotient. And that's because really what we say is that R divided by S is K, since S times K is R. Okay, so we're going to represent division with a few different, well, really with two different visual representations, okay? And I think they're kind of really well expressed with some examples. So we're going to dive into the examples and kind of use those to help guide us for this. So let's say I have 24 cookies. Maybe they're homemade. That I want to divide equally among 3 people. How many will each person receive? All right. So when you kind of think about how you would draw this, I think, and at least for me, when I kind of think about how I would draw this example here, I kind of feel like I would draw 24 cookies, sorry, and then actually create 3 equal groups, like kind of divided into 3 equal groups. So here, that's what I'm going to do. I'm going to draw 24 cookies, which is going to be circles because I'm so boring. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, cool. 24 cookies. Okay, and if I'm going to divide it into 3 equal groups, that means I would divide them like that so that there are 8 cookies in each group. So that means person 1 is going to get this. This would be given to person 2 and then person 3. And the way we're answering this question is we're saying, okay, so when I take 24 and divide it by 3, each person is getting 8 cookies. Okay, 8 cookies each. So each group contains 8 cookies. This is called, by the way, it has a name, this type of method of drawing. This is called the sharing concept. Or the partitive concept. Okay. And it uses this idea that we start with the large group of what we have and then divide it into equal groups. And if you didn't know that we were going to have 8 in each group, what you really could have done is had like started like, okay, so here's person 1's share, person 2's share, person 3's share, right? And had been like, okay, I'm going to literally count them out. 1 cookie, 2 cookie, 3 cookie, like, and then count them all out until I'm finished counting out all my cookies and I have no more cookies left, right? Okay, that it could have gone down like that, where we count out into how many in each category would go. All right, in order to actually divide it up if we can't do it easily. There is another example that kind of uses the same idea, but I'm going to kind of reword the example a little bit for this type of concept. So suppose instead I don't want to divided among 3 people. Let's say this time I want to give each person 3 cookies. And this is of the 24 I've baked until the 24 cookies are gone. So I'm just kind of mentioning the initial amount of cookies. How many people would I give cookies to? All right. So for this one, we kind of set this a little bit differently when we draw this scenario, because in this one, I know each person's going to receive 3 cookies. So I kind of already know that when I start off here, so here's one person and they've got 3 cookies. And I'm like, cool, another person's got 3 cookies. And I keep going until I have counted out all 24 cookies. Between all the people. And I'm like, okay, so this time though, I'm counting how many people I've given this to. So for a total of 8 people. So this time I've taken 24 and I divide it by 3. And what I'm saying is that 8 people are going to receive 3 cookies before I run out. Okay. This is called the subtractive concept. Wow, I like stumbled over saying that. Even though I actually said it right, it still felt weird and foreign in my brain. The subtractive concept, also known as the measurement concept. And it's the idea that we're consistently subtracting 3 every time. And this kind of builds on the idea of division anyways, because multiplication is repeated addition. Division is repeated subtraction. So we're subtracting over and over again 3 until we're done, right? That's the subtractive concept. So it's kind of nice because it displays the idea of division like how we do with multiplication, this repeated subtraction. Okay, now let's kind of view this from the angle of the base 10 pieces that we had been working with previously. So let's say we want to compute 48 divided by 4. It's a funny looking division. Sorry, 48 divided by 4 using base 10 pieces. Okay, so what I kind of sit and think about is, all right, maybe I should start by drawing 48 with base 10 pieces. So let me go ahead here and do it this way. We'll use the red. So 48, so 4 would be, 4 in the 48 would be 4 tens, right? So I'm drawing the skinny tens rectangles. Those represent 10 squares divided up. And then 8 little single rectangles. I'm sorry, squares, each one representing a 1. So 4 tens, 4 1, I'm sorry, 8 ones, and there's the number 48. Okay, so if we're dividing this by 4, my initial thought is it would make more sense to use the sharing concept in this case because I started with the total. I'm looking at the total and I'm thinking now, okay, so how do I divide this into 4 groups? So I'm going to start with the tens pieces. So I'm going to take and apply each tens to its own group. So all the tens are now accounted for. And now I'm going to take the ones and kind of do the same thing. Apply this to this one. Here. Here. And here. Which means each little group here, I'm drawing those 2 in each group. Okay. So then we're saying, all right, so how much does each group actually have? Oops, sorry, let me do that in green. So group 1, 2, 3, and 4. Each group has actually 12, since I have 1 10s and 2 1s in each group. So 48 divided by 4 equals 12. And that's because there's 12 in each group. All right. So this is the sharing concept, as I said. The sharing concept. If I wanted to do this using the subtractive concept, I need to kind of think of it differently instead. So coming back this time, I'm not going to emphasize then that I want to use the base 10 pieces. I mean, I am going to use the base 10 pieces, but we tend to think about doing the smallest amount of piece drawings that possible, right? When we're thinking of the base 10 pieces. So if I want to use the subtractive concept, subtractive concept, that means I'm taking the 4 as the measure I'm doling out to each group. So there's 4, and there's 4, and there's 4. And I need to repeat this as many times as possible. 5. And it's at moments like this, I wish they didn't use squares. I wish they used like circles. That would be easier to draw than these terrible little squares that I do a terrible job drawing. I'm sure some of you draw much better than me and laugh at my terrible drawings. That's fine. That's fine. Laugh away. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times we're able to distribute 4, and therefore this comes out to 12. Because we were able to create 12 groups. And we're using the ones, right? Each little single block, which is why it's not as ideal as the sharing concept for this particular problem. All right. Okay, so let's come back and do another one. Now this one, I'd encourage you, pause the video, try it, okay? And so for this one, if I wanted to do 378 divided by 3, what I hope you immediately say is, there is no way in the world I want to do the subtractive concept. I'm not going to draw 3 through, until I'm finished with 378. That would take forever. So use the sharing concept, okay? Pause the video, use the sharing concept, draw this out. I'm going to go ahead and continue though. So I'm thinking base 10 again. So I'm going to start by taking 378 and I'm going to draw it. Oops. In the base 10. And since I have 300, I'm going to draw 3 hundreds boxes. And then 7 would be 7 of these 10s rectangles. Sorry, 1, 2, 3, 4, 5, 6, 7. Okay, and then I'll have 8 ones. Sorry, I'm kind of squeezing it into one spot. 1, 2, 3. Okay, there we go. So I want to divide this into 3 groups. So the hundreds is pretty easy to do. I'm going to try to give myself just a little space here. So, okay, 1 group, 2 groups. Oops. 3 groups. Okay. Okay, there we go. Now I'm not going to do all the arrows like I did above. I'm just going to kind of group the next groups up. Okay, so I will have, let's see. So I can't divide evenly by 3, but I can give 2 of these 10s to each, right? So here, I'm going to display that now. So there's 2 of these 10s in each group now. Okay. And then with this last 10, I'm going to go ahead and convert it to 10 of these squares. And 2 and 2. Okay. Wow. Just terrible drawings. It's fine. I don't know why I'm stressing about it. Okay. So now for each of those, if we're going to divide, let's see, how many do we have? We have 8 plus 8, which is 16, 17, 18. Okay. So if we're going to divide that into 3, that means we'd be giving 6 each. Okay. So here, I'm going to circle it. So there's 6. Here is 6. And there's the remaining 6. So each group gets 6 ones. I'll just kind of draw them underneath because I didn't give myself that much space. They get worse as I go. Oh, well. All right, there we go. Okay, so now in each group, kind of looking at each group here, scooch this up a little. Oop. Okay, I have in each group 100, 2 10s, 6 ones. So 126 in each group. So that's the answer. 378 divided by 3 gives me 126 for each group. Make sure you write the answer when you're done with these drawings. That way, you know, we actually do the work. Okay, cool. There it is. That's how we visually represent division. I felt like it's kind of really nice to do it by example because of all that we've done. It kind of makes sense. All right, so let's look at mental calculations. Interestingly enough, I really think there's only one that's actually like kind of new for the mental calculations. The other is kind of stuff we've seen before, and some really major copping out with some rounding. We'll get there. Okay, so really the newest one, the one that's kind of special for division, is what's called equal quotients. All right. With equal quotients, this is when we use either division or multiplication. To simplify the problem. We actually use this technique a lot when we do fractions. Remember, fractions are just a division. So when we reduce fractions, quote unquote, we're using this technique. Okay, but we're trying to steal that and use it for calculations that maybe we'd like to just do quickly in our head. So let's say, for instance, I want to divide 144 by 18. Now, right off the bat, I don't know what that is. Like 144 divided by 18. I have no clue. So, what I do know is that both 144 and 18 are divisible by 2 because they're even numbers. So if I divide them both by 2, 144 is going to become, let's see, 2 goes into 14, 72. And then 18 divided by 2 is 9. And I actually happen to know that. That's like multiplication tables. 8. 72 divided by 9 is 8 because 8 times 9 is 72. Cool. Now, could I have taken a different approach? Could I have divided both of them by 3? Sure. But I don't think most of us know what 144 divided by 3 is in our head. And the idea is we're supposed to be trying to do things that we could do in our head without a calculator. Okay. Okay, let's try another one. Let's try 1700 divided by 50. Now, again, I see that both of those are even. I could divide them by 2. But that gives me a 25, and I'm not very good with dividing by 25. I could divide both of them by 10, but then I have a 170 and a 5, and that just doesn't seem all that much easier to me either. So I'm going to try the other thing that they mentioned. We could multiply, and multiplying 50 by 2 is like my favorite idea because that's going to give me 100. And 100 is much easier to work with. Okay, so let's see. 17 times 2 is 34. 100. 50 times 2 is 100. That's much easier. 34. There we go. So sometimes we have to kind of either we can multiply or divide, whichever one actually gets us to something more reasonable. And there are definitely multiple paths to do this, okay? So I'm going to give you one. Why don't you go ahead and try it? Actually, I'm going to give you a couple. So here, try this one first, though. Let's try 180 divided by 12. Pause the video, give it a try, divide both of them or multiply both of them and see. Okay, and let's say you have unpause the video. I notice, and I'm going to try to, make my life as easy as possible. I notice that 6 goes into 18 and 12. And I'm looking at the 180 as 18, right? I'm seeing the 18 in the front. Okay, so then 6 would go into 18 3 times with a 0. 12 divided by 6 is 2. That gives me 15. Again, there are other ways to do it, but that's just what I saw. Oh, and I'm going to mention, especially right here, 336 divided by 48. If you want to pause the video and try it, that's fine. I actually use 2 divisions to do this one. Okay, just so you know. Okay, so when I look at this one and I want to try dividing, I kind of see the 336 and I can't help but say that's divisible by 3. And I do happen to know that 48 is divisible by 3. It's one of those numbers that I've divided enough by 3 to know that it works. Okay, so 336 divided by 3. I could actually do that. That's 112 without a calculator. You may not know 48 divided by 3. I do happen to know what 48 divided by 3 is. That is 16. Now, I don't know what this is, but I do notice they're both divisible by 2. So I'm going to do it again. And then I'm like, okay, so let's see. 112 divisible by 2 is 56, right? Because I'm thinking of the 100 and then the 12. So 56. And then 16 divisible by 2 is 8. And then 56 divided by 8 is 7. So there we go. I did that one in 2. And you could do it in reverse. You could do it by 2 first and then 3 the second time. That one's actually not too bad. Or actually, you know what? I'm going to show you an extra one just in case. Maybe you took a different path. You could do it by 2 twice. Let's do that. Let's say we didn't notice 3 worked. And we do 2 twice. Okay, so let's see. 336 divisible by 2 is actually 168. And I only know that because I divided on the calculator. Divided by 24. I know the point is not to use a calculator, but we'll pretend for a second I was able to do that in my head. And then if I were to divide it again by 2, well, I could do it in my head. I just have to do the long division version. Or actually, oops, I'm going to go away. Thank you. Divided by again. And then this time, let's see. That's going to give me 84 divided by 12. And I happen to know that one of my multiplication table friends there, that's 7, which matches the one we got above. So you could have done it twice by a number of 2, if that's all you saw. It's possible. I do think that going from 336 to 168 is kind of hard to do in your head, but I was able to do 336 divided by by 3 in my head. Like that one was a little bit easier for me. All right, so there you go. That's the equal quotients. Now they jump into approximations. And man, they jump into this hardcore. And I'll be honest with you. Oops, sorry, I wanted to do that in blue. I had a hard time distinguishing between their directions on approximations. They all kind of started to blend together for me. Okay. So I'm going to write out the directions as I do this. So that way you can kind of see. Okay. What they say and the subtle differences. But man, it's so subtle. It's hard for me to really make much difference between them. Okay, so the first directions they say is approximate. And here I'm going to abbreviate approximate just because I'll be writing enough. By rounding one or both digits. One or both numbers. Okay. Part A, let's divide 472 by 46. Okay. So I definitely can't do that in my head. I am going to have to round. So let's see. If I were to round this, I'd probably naturally round 472 to 500 and 46 to 50. I would probably just like naturally round the numbers like according to kind of almost the traditional sense where I'm looking at the first number and making it nice and whole and using the rules of rounding, right? The number next to it is bigger than 5, so I'm rounding it out. Okay, so 500 divided by 50 is 10, and I'm like, cool. I feel good about that. Okay, let's try another one. Let's say we have 145 divisible by 23. Okay. So for this one, here, this time I'm not going to use the front number. I'm going to kind of see if I can make it work with a little bit smaller amount of rounding. So rather than like round to 120, right, which I could, which wouldn't be that bad. 100 for the first number, 20 for the second number. I'm kind of tempted to round this to 150. That's, you know, a nice clean number, 150 for the 145. But then I'd be maybe motivated to round the 23 to 25. Not 20, only because it wouldn't go in nicely. But well, it does go in, not that bad. But to me, this is really easier for me to figure out in my head because I think of quarters and I'm like, okay, how many quarters goes into $1.50? 6. So to me, that was a little bit easier to do in my head. Again, I could have potentially rounded it to 100. I can write tonight. This is just giving me trouble. And 20, like using the traditional rounding of the first number, I could have, and that would have given me 5, very close in terms of approximation, right? But yeah, I chose to kind of show you a different way. It's very loosey-goosey. Okay, another example with different directions. So this time, the directions say, approximate first. I'm sorry, approximate, let me abbreviate that again, by first rounding, by first rounding, that's supposed to be a U in the middle of there, then using equal quotients. Okay. Equal quotients. Okay, let's try it. So equal quotients is what we talked about earlier when we divide or multiply by a number to make our life a little bit easier. All right. So now they do 427 divided by 72 for this example. All right, so 427. I'll use my kind of semi method here where maybe I'll divide that to 430. I'm sorry, round it to 430 and then to 70. I don't know. I'm kind of taking a stab at this. In that case, if I'm going to use the equal quotients, I'm going to divide both numbers by 10. Now that doesn't actually give me something all that nice. So they actually round the 43 to 42. And they're like, well, it's close enough. We're approximating anyways. And 42 is divisible by 7, so that's 6. So they kind of do another approximation here. That's how they did this in the book. And I kind of was like, huh, all right, we'll go with that. Could I have rounded this a little differently? Yeah, I could have. But when I kind of like played around with it, there was nothing really all that much easier to work with. There really wasn't. So using the rules of rounding and yeah, you kind of end up doing this like weird cheating approximation thing in the middle. All right. Let's try another one. I know I'm probably making you feel like it's very loosey-goosey. This one's a lot more straightforward. And in fact, the rest of the examples are a lot more straightforward. That to me was the weirdest example they gave. I was kind of like, all right. All right, so this one. On this one, I'm going to go ahead and round the 92 to 90. And then I'm going to go ahead and round the 9 to 10. And I'm going to do that only because I felt like they gave the instructions to round both numbers. At least that's kind of how I took it. First rounding, then using equal quotients. And then I'm like, okay, cool. Both of these are divisible by 10 because they want us to use equal quotients. So I'm like, all right, so that gives me 9 divided by 1, which is just 9. And I'm like, cool. They did do it a little different in the book. They chose to not round the 9, leave it at just 9. They only rounded the 92 and took that approach. But honestly, I feel like it's a little bit loosey-goosey. Therefore, I'm going to accept your answer if it's rounded a little bit differently than maybe I would have done it, as long as it makes sense, as long as you're kind of following the instructions. You rounding first, then using equal quotients. Great. So don't stress. Do your best and try to round and approximate because it is an approximation. Okay, now this one, use compatible numbers. So with compatible numbers, you might remember, sorry, sometimes the screen pauses or like stops like showing my work as I'm like writing or erasing. Like right now, I tried to erase what I had scribbled on there and it's like not showing me that it's erasing. And I kind of give it a moment and sometimes it just needs me to try again. So I apologize. Sometimes I have these weird pauses and it's because the computer's catching up to me. Okay, use compatible numbers to approximate. Again, I'm going to abbreviate approximate. Cool. Now, this definitely feels like I'm doing the same thing. Like I honestly could hardly tell the difference between these problems and the ones we were just doing. So if I'm going to round this or use compatible numbers, basically you're going to round it. You're going to try to pick numbers that are easier to divide. So I'm like, okay, well, 59 is close enough to 60. 16 is very close to 15. And I like 15 because 15 does go into 60. So I'm motivated to go ahead and sorry, I couldn't tell if it had froze up or if I needed to write it again. I'm going to go ahead and kind of think of it as a little bit, 16 is close to 15. So I put one up, one down. 60 divided by 15 comes out to 4. I'm like, cool, that's all right. That doesn't work too badly. All right, let's try another one. 78 divided by 21. Okay, so I'm trying to pick numbers that are a little bit nicer for me to work with. So I'm like, okay, well, 78 is very close to 80. And if I'm having 80, I'd sure like to turn that into 20. That's very close to me. So that again gives me 4. That's just by chance that they both came out to 4. All right, well, cool. There you go. So that's how we could use compatible numbers to approximate. It kind of feels like you're just rounding, but you're rounding the numbers that you know divide. So you can round up or down a little bit just to make it work. Okay, now the last thing I mentioned that's in this section is exponents. And they don't spend a ton of time on this. They just kind of introduce it now that we've talked about multiplying and dividing. They kind of bring it up now. So exponents is a shorthand for a repeated addition. I'm sorry, repeated multiplication. Wow, that's supposed to be the word repeated there. Let's try that again. Repeated multiplication. See, I tried to be smart and look what happened. The computer got mad at me. Anyways, so let me write it in general. If I have b to the n, that means that I'm taking the number b, whatever it is, or variable, because variable is just a number anyways, and I'm multiplying it by b repeatedly n times. All right. We call b the base. So that number that we are raising to the power or exponent is the base. And then n would be the exponent or power. However you want to refer to that. Okay, let's just look at an example so we feel good about it. And then I'll show you why they bothered waiting until after division to introduce this. So let's find 2 to the 5. So that means I'm taking 2 times 2 times 2 times 2 times 2 times 2. And if you want to do this really quick, it's actually not too hard to do it in your head. If you want to pause, but I'll just tell you the answer. It's 32. Okay, now they're like, okay, now that we kind of understand how exponents work, what if we had 2 to the 5 times 2 to the 3? And you're like, huh, okay. Well, 2 to the 5 is 2 times 2 times 2 times 2 times 2, 5 times, right? That's 2 to the 5. Here, I'll put it in parentheses. Times, okay, you don't need the parentheses. This is just so I can show the grouping of the numbers. Times 3 more 2's, 2 times 2 times 2, 3 times. So what I really have, though, is 8 2's here, right? 1, 2, 3, 4, 5, 6, 7, 8 2's, which I could be cute and write as 2 to the 8, right? I could drop those parentheses. They're not necessary. And now I just have a multiplication of 2 8 times, even though I partially erased that too. And 2 to the 8 actually ends up coming up to 256. 256, I did double check. I was going to say 128, but I think that's 2 to the 7. Cool. All right. Now, this is actually kind of useful to see that really what we've done, I hope that you see, is that 5 and 3 are giving us the 8, okay? So kind of seeing that, let's look at this one. Let's do 2 to the 5th divided by 2 to the 3. So now we're doing a division instead. Okay, so if I'm going to do a division, I'm going to go ahead and set it up as a fraction because that'll be easier for me to understand this. So in the numerator, I'm going to put 2 times 2, 5 times, right? 5 2's. In the denominator, I'm going to put 3 2's. And then I'm going to notice that every time I have a 2 over 2, that's a 1. That's really just a 1. 2 divided by 2 is 1. So this gives me 2 times 2, which if I wanted to as a shorthand, 2 times 2 is 2 squared, which is 4. Now I'm writing the shorthand because I want us to notice that when we had a 5 divided by 3, we end up with 2. Okay, so what I'm hoping you see is the exponent property or the laws of exponents that they list out. And that's that if you have the same base and you do multiplications or divisions with things that have the same base, you can actually shortcut those multiplications and divisions, okay? So here's how we would do that. So let's say I have a to the n times a to the m. So same base, different exponents. What we can do is add those exponents together, and it would just be a to whatever n plus m is. It works for division similarly, except this time you would subtract the exponents. I am assuming, by the way, that n is bigger than m to make our life easier. Okay, so that's going to be the case for this, and we'll kind of stick to that for right now. Okay, so the last little thing they do is they dip into order of operations. It's supposed to be example, and it's just getting slower and slower with writing. Okay, so let's say we want to do 160, and it'll eventually finish drawing 160 divided by 2 to the 4th plus 2 to the 7th. Sorry, that's kind of a sad looking 4 minus 75. So those are exponents. 2 to the 4th, 2 to the 7th. We're doing order of operations. So remember, order of operations, PEMDAS, parentheses first, then exponents, followed by multiply, divide, which are equal, and addition and subtraction, which are also equal. Okay, so according to this, I don't have any parentheses, so I'm going to start with these exponents. I do happen to know that 2 to the 4th is 16. And I also happen to know that 2 to the 7th is 128. How do I know? Well, I teach math. So I do these kind of numbers, so I kind of remember some of them. All right. Oops, that's supposed to be division, not an equals. And that actually ends up working out very nicely because next thing I'd want to tackle is division, since that's what's next here, left to right. And I'm going to tackle this 160 divided by 16 actually goes in very nicely. That's a 10. And now I'm going to go ahead and do the addition first, since it's left to right. 138 minus 75. And then last step would be that subtraction. I get 63. And there you go. There is division and exponents.